Can you both hear me?
Yes, sir.
Let's start. So yesterday we saw what? Isothermal and adiabatic. Now we'll see isobaric. Same thing, what we saw before also. At constant pressure. So dq will be ncp dt. Then du will be, let's write this here. Du will be ncv dt and dw will be p v2 minus v1. Isochoric process, volume constant. So work done means dw is 0. So dq is du, which is equals to n cv dt. Then last what we saw, what we are left with, cyclic. D. So V1, V2, cyclic process, this direction. In this one, see, initial state and final state are same. Initial and final state are same. So du equals to 0. So uf minus ui and dw equals to area of cycle, which is here A, B, C, D. slope of adiabatic and isothermal curve. Have you done this graph? It's the same actually. If you don't do, it's, since still it is same only what we wrote before, the starting of the chapter. Slope of adiabatic and isothermal curve. Now from here, like this is something new little. So for isothermal, PV equals to constant. So if PV equals to constant, so if we differentiate P into V, D means it is dW, so D like that. If we differentiate this one, so what we'll get P first, we will write dV plus V. Next, we will write dP equals to 0. So if I draw this curve, okay. This is isothermal. This is there is only a very small difference in curve, so you might get confused here, but just see the slope, whichever is steep and all that. Okay. Slope of isothermal is dP by dV equals to minus P by V for isothermal. For adiabatic, adiabatic process, PV to the power gamma equals to constant. So in the same thing, if we differentiate, we'll get same. So dP by dV equals to minus gamma P by V. So with this value, we can conclude that slope of area is, from diagram also, more steeper than isotherm. So we can write here gamma equals to Cp by Cv. Done? Aditi, Janvi,
Yes, sir.
what about Janvi? Okay, then I'm scrolling up. All this theory, like almost over. Now we'll see all different types of graph and all that. So till now, any doubt? Any theory, anything? Because we will see only graph. So what graph represent and how it is, like I'll just give you overall ideas of those all the graphs. We'll draw some 10 by 10 graphs. So if you have doubt, you ask me, because this graphs is from this theories only. All this, whatever we studied till now. Come on. Aditi, any doubt till now? Anything you want to know in this till here in this chapter? Aditi?
No, sir.
No? Okay. What happened to your throat? Not good?
No, sir. Actually, we went to this like field trip, and I'm just too tired.
Oh, okay. Because your sound is different. Yeah. What about Janvi? Any doubt till now? I couldn't hear you. Then shall I start drawing graphs?
Yes, sir.
चलो ठीक है फिर. And why was I asking? Because if you know all this theory, then only you can understand graph easily. Graphs of thermodynamic process. Let's start with this one. P in this axis, y-axis, and V in x-axis. So A, this is B, this is C, direction this way. Same way A, B, C, direction this way. So let's name graph 1, graph 2. For graph 1. So if you observe here, A and B and B and C and C and A, there are different processes going on. If you can tell me, instead of writing this here, I'll write in this one. AB is your, what I wrote here, isothermal. Then B and C, it is straight line. So in this one, volume is not changing here. See, volume is changing, but pressure is constant. So this is isobaric. In this one, volume constant. So isobaric. Are you able to identify with me? Girls, both of you?
Yes, sir.
Isochoric, because here volume constant. In isochoric, we have volume constant. In isobaric, we have pressure constant. If you can't remember, just go with the name bar. Right? Bar means unit of pressure. 1 bar atmospheric pressure 10 to power 5, like that, right? So baric. Isothermal. Thermal means heat. So isochoric. That is volume. Now you tell me for second graph. This is your pressure and temperature. From this one, I can draw this graph as isothermal graph as this one. Pressure and temperature graph. Pressure constant, temperature constant, varying directly, like that way. So let's go for second. If you want to write in your own words, you can write. Pressure, y-axis, volume. So there are two processes in this one. See, pressure is changing with volume. There, upward. See, upward, process 1. Heat is absorbed more than second process. In one, see, heat is absorbed more than second process. Why? How can we say that? Because of area under this curve. See this, if I draw this area under curve, this is more as compared to this green lines. So make a note of it, this also, because area under 1 is greater than 2. So if area under curve 1 is more than 2, that means work done also more, because what we said before, work done is area of the cycle or area under the cycle or whatever way you want to remember. In 1 is more than 2. But one thing is important here, that is, let's say, star mark. What is it? We spoke about heat, we spoke about work done. Then what we left? What we are left with? We spoke about heat, we spoke about work done. Something is left here. Yes?
Temperature?
Yes, internal energy. What will happen to internal energy? It will be increasing or decreasing, or any other option you want to give. Come on, what will happen? No idea? Go back to your process. See there, we said heat energy, heat is absorbed. Okay, work done is what? Area under the cycle. So internal energy is not changing, so is same in both cases. Third one. So we wrote graphs for curve, that is first and second we saw. In that isothermal, we converted isothermal in PT graph. I mean this PV graph into PT graph. See, when we are converting PV to PT, observe this. My volume is, sorry, I mean pressure is changing here. So change of pressure, you can see from here. Same points, A and A, B and B. Change of pressure. CB, pressure is constant here. Here also CB's pressure is constant. CA, pressure is increasing again. So here also increasing. But as pressure is increasing with temperature. In next graph we saw whichever area we observe that area under this, whichever the higher area, that will be the more heat absorbing. So in this case, first one is absorbing more heat as compared to the second case. Then third one, there are like some more 10 graphs we'll draw, but I don't know if we can finish today or not. So if you understand this 10 graphs, that's it. Over this chapter. Any graph they ask in exam, you can solve it. So let's draw this too. Make this curve actually. I'm not able to draw this curve. Yeah. Because this is PV graph. And P, this time we will draw VT graph. Let's name it A, B, C. It's going from A to B, B to C, C to A. So A, B will be volume is changing here. A to B, volume is increasing. So let's draw A to B. Now B to C, constant volume. So let's draw constant volume. Then C to A should be changing volume, means decreasing. So it is decreasing. Got it? How I drew this graph? I'm following the first graph. Before also I did same, but I didn't say anything. I just drew final answer. But got it? In this one, what we did here, PV, we are drawing PV graph with respect, means corresponding graph is your VT graph. That is A, B, C, D. No, not D. A, B, C, A. This is for ideal gas. For isochoric process. PV, VT, and PT. PV, VT, and PT. One, two, 1, 2. Same, 1, 2. Same thing what we did here. Similar way we are drawing all the graphs. Yes, I think so. We can finish all the graphs today. Are you done? Shall I go for next? Let's. Till then, I'll give a heading for isobaric process. PV, PT, VT. Done? Shall I scroll up? Adi, Samhita, Janvi, done?
1 minute, sir.
Oh, okay. Isobaric, then isothermal. That's it. What's the next class timing? Is there any class today? 8. 8:45. Yeah, then we can continue. I can finish this
Done, sir.
graphs. Yeah, then we can finish this graph today. Isobaric process. Let's draw 3 graphs. You can start drawing 3 graphs. This was PV, right? This is PV. Wait, let me write this. Okay. This is your P and V. Because I have drawn Parik, so this should be P. I don't want to change. So P, T, and V, T. So pressure constant here. This is a straight line. So okay, you draw a straight line, not last one will be linear graph. Push fifth, sixth. So isothermal. Again, draw all these three: PV, VT, and PT. So thermal means we need a temperature constant. So if I take PV here, then VT should be here, then PT. So PT. So I want temperature constant. So in this case, temperature constant means rectangular hyperbola or hyperbola, we can say. Then here temperature constant means this line. I'm not doing anything new, same thing. Here pressure and temperature constant means here this line. So let's write key points. Keep in memory. If you're done, I can scroll up. I want to see the theories what we wrote so that I can come up with some points. Are you done?
Yes, sir.
Samhita?
Done.
Chan. Janvi, you also, right? Okay, so let's see the graphs. Okay. Fine. So let's make one point. From the first topic. This one and internal energy. This will write. In this thermodynamics, heat, work are not state variable. Internal energy is, but is. And those equations we can we can write here. Relation between P and V, PV to the power gamma equals to constant, then V and T, TV gamma minus 1 equals to constant. P and T from these graphs T to the power gamma P1 minus gamma equals to constant. And one thing we didn't write here. So do you know about quasi-static process? Static process. Static means steady. So very, very, very slow process. Slow process. Put pressure, volume, temperature, and mass. They all are like here from this first point I'm writing are state variable. But heat and work are not. The same thing what we wrote, these points. Just conclusion. Then we'll go for engines and second law. That's it. Over. Carnot cycle. Hey, when we started this chapter? 5th. 5 days. Okay. Okay, done. Shall I stop sharing? Samita?
Yes, sir.
Done?
Yes, I'm making screenshots. Yes.
Oh, okay. Aren't you writing?
Sir, I joined late today, so that's why I'm making screenshots.
अच्छा ठीक है ठीक है okay then bye bye everyone
Bye, sir. Thank you.
yo bye bye